Okay, this video is for lesson 2.4. It's the first part of the lesson. We are going to be factoring and solving polynomials. So the objectives are going to be, I can completely factor a degree 2 polynomial, and remember that's a quadratic. And you are also going to be able to factor a higher degree polynomial by using the greatest common factor. So these first few things on the page are just some review from what we did in Chapter 1. We learned how to factor the following types of degree 2 quadratic equations. We did a trinomial, and in the trinomial we had to find numbers that multiply to c but sum to b. Okay, and we have an example over here. So even if there was a leading coefficient other than 1, we were able to do that. And then we also had a perfect square trinomial, and we also had the difference of two squares. And so we're going to practice a couple of these just to remember how to factor those types of polynomials, and then we're going to get into how to factor something that's a little bit more complicated than that. So let's take a look at our first example. So the first example here says to factor each trinomial completely. So I have a c, I have a b, and my a here is understood to be 1. So what two numbers do we know that multiply to 28? So first of all, you're looking for two numbers that multiply to 28. Are they 4 and 2? Sorry, 14 and 2. Are they 4 and 7? And they also have to add to negative 11. So two numbers that multiply to 28 but add to negative 11. Well, it seems to me like that's going to be negative 4 and negative 7. Okay, when we multiply negative 4 and negative 7, that equals positive 28. But if we add negative 4 and negative 7, then that means that we have negative 11. So there's our answer. All we're asked to do is factor. We're not solving here, so we don't have to set those equal to 0. And in this next one, we have to find two numbers that multiply to negative 6, but sum to positive 1. Well, negative 6 and 1 multiply to negative 6, but they don't add to positive 1, so that doesn't work. But if I did positive 3 and negative 2, that would work because they sum to positive 1 and they multiply to negative 6. So I'm going to write my answer out like this, and this is the factorization of that polynomial. All right, so I would like you to try problem C on your own, please. And let's go ahead to recall for these type of problems here in example 2. And these are just binomials. And if you notice, there's a subtraction symbol. Okay, subtract means difference. And if you recall, if we have the difference of two squares, and 4 is a square, x squared is a square, 9 is a square. So we can set this up so that we have two binomials. If we take the square root of the first term here, we get 2x. If we take the square root of 9, then I'm going to get 3. And all we have to remember is that we need to put in a plus in one binomial and a subtraction sign in the other binomial. So there's our final answer. That's the factorization there. So the difference of two squares, you're taking the square root of the first term, the square root of the second term, and we're going to put those in two binomials. So 9x squared, the square root of 9 is 3, the square root of x is x. Sorry, square root of x squared is x. So I'm going to put that in the beginning of my two binomials, and then I'm going to have the square root of 16, which is 4. And just remember that we have to have a plus in one and a minus in the other. And there's my final answer for that one. So I would like you to finalize this section by finishing up problem C, please. All right, on the second page, the back side of your notes, we are going to be taking a look at the new information, factoring higher degree polynomials using the greatest common factor. When the degree of the polynomial is greater than 2, and all of the terms share a common factor, you should always follow these steps in order to attempt to factor the polynomial completely. So in step number 1, we're going to be looking for the greatest common factor between all of the terms of the polynomial. And once we find that greatest common factor, we're going to divide each term by the greatest common factor. So If I say what this polynomial really is, I can break it down to the fact that this is 2 times x times x times x. That's what 2x cubed really means. And then if I look at the second term, I would be looking at 2 times x times x. That's what 4x squared really means. And then if I look at the number 30 and x, that's going to be 2 times 3 times 5 times x. Okay, so really what I've done is I've done a prime factorization of each of these. So what is common between all of these terms? Well, it looks like I have a 2 and an x, and I have a 2 and an x, and I have another 2, and I have another x. So that means that is what the greatest common factor is. So I'm going to divide this by 2x, this by 2x, and this by 2x. So what's left? Well, if I cancel that, the only thing that's left is x squared. If I get rid of this, because I'm dividing, all I have left is 2x. If I get rid of this, then all I have left is 15, and I have to remember that there was a negative sign right there. So once I divide everything by my greatest common factor, which in this case is 2x, notice where I'm putting my 2x. For step 2, it's telling me to put in parentheses what's left. So I have my x squared that's left from this when I divided this. I have my 2x from this when I divided the second term by the greatest common factor. And I have negative 15 from when I divided this information. Okay, so if you have to, you can do the prime factorization sort of like I did, but that really is something that you can do in your head. I just wanted to make sure in this instructional video you can see what I was doing. So what's left goes inside the parentheses, the greatest common factor goes outside the parentheses. Now, in order to factor this polynomial completely, we have to address the information that is inside the parentheses. So this can be broken down a little bit further, sort of by using one of those methods that we did on the front side. So what we're going to be trying to do is we're going to try to find two numbers that multiply to negative 15 but sum to positive 2. All right, so two numbers that multiply to negative 15 but sum to negative 2. Well, I think that positive 5 and negative 3 would work here. So we can say now that 2x is our greatest common factor outside the parentheses. We're going to make two new binomials, and one of them is going to be x plus 5, and the other one is going to be x minus 3. So now I have my greatest common factor, and I've factored the trinomial, this one in the parentheses, completely. I'm going to do a couple more here in example 3 by following those steps that we just mentioned. I'm going to do problems A and C, and then I'm going to ask you guys to do the B and D problems over on the right-hand side. So the directions say to factor the polynomials completely by first factoring out the greatest common factor. So once again, if I do a prime factorization, the first term has 2 times y, and that's going to be 5 y's multiplied together. And if I do a prime factorization of 18y cubed, that's going to be 2 times 3 times 3 times y times y times y. All right, so all I did was break down the 2y to the 5th and 18y to the 3rd. So if I gather up the things that are alike, it looks like I have 3 y's, and I have 3 y's here. And I also have a 2, okay, in common with the two terms. So I can say that my greatest common factor is 2y cubed because there are 3 y's multiplied together. So if I divide both of those terms by 2y cubed, what is left? So 2y cubed is going to go outside the parentheses. And what's left are these two y's here. So it's going to be y squared minus 9. That's all that's left over here. And now inside the parentheses, it looks like I have a difference of 2 squares because 9 is a square and y squared is a square. So now to break this down even further, I'm going to say y plus 3 and y minus 3. All right, remember we can use the difference of 2 squares method to help us factor a binomial if necessary, okay? And there's my final answer. If you need to watch this part of the video again, please rewind it so that you can see the steps that I'm taking to factor the polynomial completely. Okay, one more problem that I'm going to do for you. And it looks like to me we have three r's, r times r times r in the first term. And then in the second term we have 2 times 3 times r times r. And then in the last term we have, let's see, that's quite a breakdown. But anyways, I'm just going to leave it as 72r because all that's in common here is one single r. Okay, that's the only thing that all three of these terms have in common. So if I divide this one by r, this one by r, this one by r, I'm going to have an r, and then I'm going to have r squared, because that's what's remaining after I divide, and then I'm going to have minus 6r and minus 72. And now all I have to do is take care of the information inside the parentheses. And I'm going to be looking for two numbers that multiply to negative 72, but sum to negative 6. And those two numbers are going to be negative 12 and positive 6, because negative 12 times 6 is negative 72, but negative 12 plus 6 is negative 6. So over here is going to be my final answer. R plus 6 and r minus 12 are my two binomials. And then don't forget that you have to keep your greatest common factor there as well. Now, if you wanted to check and see if this is correct, you can always go backwards and FOIL the information in the two binomials and then multiply it by your greatest common factor. You should always end up going back to the original polynomial. So that's how you can check your work if you think you've done something incorrectly. So if you have questions about anything from this video, please make sure you write them down or make some notes to yourself. If you need to watch this video again at any certain point, please go back and do that. But we will have some practice problems in class tomorrow.